Alright, welcome to Scholars Forum. How we're doing today. Today we'll be discussing something very important in mathematics. We're talking about elementary sets and theories. I believe as you are home, you're enjoying yourself, but then please take out time to watch this video over and over again, as this is just a starting of our digital Scholars Forum for now, since you are home. So starting with us today, we'll be dealing with set theory. Alright. Now, in set theory, we further explain that set theory is a collection of unique items or a collection of unique objects in a rectangular set. Now, what that means is that each of the objects in a set is unique. Suppose this is a set. I will name this set A. Alright, now you can observe that A, B, C, and D are different items. There is nothing similar with them, except for the fact that they are all alphabets, okay, but then they are all different alphabets. Right? This is A, this is B, this is C, and this is D. In a set, there should be no ambiguity. Now, when we say no ambiguity, what does it mean? There should be no conflicting words between any set at all. Should there be a set A and a set B, in A, B, D? Alright, now inside the same set A, we shouldn't have something that will contradict the existence of A, B, C, or D. Nothing should be here to say this is not A and this is not B. And nothing should be there to say that this is not set A and this is not set B. Alright, now for no ambiguity, as we explained, there should be no confusion in a set. The next part is no repetition. No repetition of elements in a set. So in a set, we do not repeat elements. So if you write anything like this, A, B, C, D, it is wrong according to sets. Alright? But with something like this, if you have A, B, C, D, and you have B to the A, C, D, if you were to join these two sets together, which we will discuss very soon, we'll call that union. If you were to join these two sets together, in as much as A is existing here and A is existing here already, you don't need to write A twice. So you just simply write A union B, giving you something as A, B, C, and D. At the end of the day, you can see that the set A and the set B give you back what set A. But then we'll discuss that in further details. Now, going further to what we have next, membership by listing. Now, every of these elements in the set A, how do you represent them when you want to tell somebody that A belongs to the set A and the element B belongs to the set A? Now we call each of these the elements, and we call this the set itself, alright? Or the set name itself, alright? This is the set, this is the name of the set, and these are the elements of the set. Now if I were to write A, B, C, D are members of the set A, alright? I simply write something like this: A is a member of set A. Alright, so element A is a member of set A. That is how we show membership by listing. The same thing goes for B, C, D, same thing B, C, D, or they are all members of set A. Now that is done for that. We go further to explain membership by property. Now basically they can represent set notations in two ways. Now we have what we call the set builder notation. The set builder notation, and we have, now let's quickly discuss this. Now, the set builder notation, we have the tabular notation. Now, in the set builder notation, what is done there is we are given a preempt, that is a summary of what exactly the set should look like. Okay, so if I say that the set A should be that it is X, such that X is an even number less than or equal to 20. Okay? Now in this case, we are looking for an even number less than or equal to 20. So if you agree with me, all even numbers less than or equal to 20 will be giving you 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The reason why we are including 20 here is because the equation sign, the equality sign said is less than or equal to 20. Alright? Now this is what we call the set builder notation. Now in the tabular notation, this is what we call tabular notation. Alright? The tabular notation is given to you straightforward. There is no extra work you need to do in your tabular notation. This is all that we have under membership by properties. Now, how do we call a subset? Okay, so take for instance now, B is no longer ABD. All right, let's take B to be B, D, and E. Now, in this case, how do you show that a set is a subset? In fact, what is a subset? A subset is any set that can be found inside a major set. All right, now what is a major set? The big set itself. Okay, so take for instance, A is ABCD and B is BDE. Now you agree with me that you can find B here and you can find D here. That makes B a subset of A. Are we there? Now this makes B a subset of A. Now B is a subset of A. Why? Because some of the elements it has are also existing in A. Some of the elements in set B are existing in set A. Now there's something else we call proper sets. Now if I write a proper set, I write it as this, B being a proper set of A. What does that mean? It means every single element in B is inside A. Every single element in B can be found in A. So take for instance, we have B, we have A, C, D, E. In this instance, automatically you can see, okay, now let's remove this. Okay, so let's add E here. Now, A, C, and D are all found in A, C, D, in set A. That makes B a proper set of A. Now, if you observe, if we switch this sign the other way around, it becomes something like this. Now, this is called proper set. But this, what do we call this? We call this the superset. Now, when you talk of the superset, the letter on the left-hand side, what it denotes is that this letter on this side houses every of the set on the other side. So if I put an A here and I put a B here, what it means is that A is a superset of B. And what does that mean literally? It means every single element in B was gotten from A. So that means A is a father to B. Exactly that point. A is a father to B. So every other set that is generated from A is still a superset to them. But they that were removed from A, they are all subsets of A. Now, going further, we have what we call the equality of sets. Now, when the elements in a set or in two different sets are actually the same, irrespective of the order in which they come. If A, this time around now, is 1, 2, 3, 4, and B is 2, 3, 4, and C is 2, 4, 1, 3. Now, you could be asked which of these sets are actually equal. Now, if you observe, you find 1, 2, 3, 4 in set A, you have 2, 3, 4 in set B, automatically 1 is missing in set B, so automatically we cannot say that B is equal to A. But looking at set C, 2, 4, 1, 3, we have all the elements of A in C, but then it is not as ordered as it came when it was in set A. That does not matter. In a set, the orderliness does not matter. It is the uniqueness of the element that matters. So far there is an element in there that shows the elements that should be in the set, then at that point you are actually correct. So in this case, if you are to add this and this together, it will be that A is equal to C. Set A is equal to set C. Now this is what we call the equality of sets. Now, if you check number listing, if A is equal to all numbers less than 20. Now, you will agree with me that it's kind of impossible to count all numbers less than 20 because you have from your negative infinity all the way down to 19.99999, which has no end. Okay? Now, let's do something more palatable. If we pick A to be all vowels, yes, all vowel sounds, and we pick B to be A, E, I, O, U. Now, we all agree that there is no difference in this. A is all vowel sounds, and B is still vowel sounds. So automatically, this set A is equal to the set B. I hope that is well taken. The next we have here, how many sets we have here? The universal sets. Now, let's clear all of this off so that we can have space for more work. Alright, now the universal set. What's the universal set? Now, like we discussed in this place where we said A is a father to all sets that we're gotten from it. The same thing applies to the universal set. In the universal set, every other set that can exist is gotten from the universal set. Now, take an example. If I put the universal set to be, now that sign is very funny. Oh, okay, I think you can manage this. Now, if the universal set is equal to all consonant sounds, if the universal set is all consonant sounds, and set A is B, D, F, G, set B is G, K, M, N, J, P, and set C is M, N, P, Q. Now let's stop here. If you observe each of these sets, set A, B, D, F, G, set B, G, H, K, M, N, J, P, right? Set C, M, N, P, Q. Observing all of the things, all of the elements in this set, they are all consonant sounds. So that means A, B, and C are all subsets of the universal set. What it means is that every of these sets are gotten from this set. That therefore makes this the universal set. I hope this idea is clear enough. Now we go further with what we call the empty set and the unit set. Yes, the empty set and the unit set. So let's look at an empty set. Now, I believe that a few of you, or many of you will be watching this, might not have been in class with us when we did things like this, but then this is for your benefit. Now, we had a controversy in class earlier this semester as per what an empty set is exactly. And I gave this illustration. Now, you have something like this, and you have something like this, and you have something like this. And which of the following is an empty set? And from the word empty, what it means is that it doesn't have any elements. Okay, so if it doesn't have any elements, how do you represent that as an answer? Should you not have any elements? Okay, so looking at this, if there's okay, now let's deal with this first before we go that far. Now, looking at this, these are curly brackets only with no elements in it. This is a curly bracket with a null sign in it. We'll call this a null sign because many were doing it for the first time. So we call this a null sign. Now, the null sign means empty. The same thing as empty. The null sign means empty. Alright, so this is null sign. This is curly brackets having a null sign, and this is empty curly brackets. Now, the thing is, which of the following can represent an empty set? Now, I have two answers here, and I'll tell you the reason why they are so. Now, the null sign says it is empty. Automatically, we can use this. So you don't have to write a curly bracket or anything else. Now, in mathematics, you cannot just write empty set. Alright, there's a way we represent empty sets. Either you put this sign down as an empty set, or you put this down as an empty set. Remember in the beginning I said it's a set with no element inside. So at this point, you can see that there is no element in this particular set. Now please, let's not be mistaken. When you are writing sets, you don't use anyhow brackets. You use the curly brackets. And the curly brackets are mandatory for sets. Even in computer science and the rest, you will find them telling you to use this kind of brackets for sets and dictionaries. For computer science, I will understand. But for the purpose of this course, this is an empty set, and that is an empty set. This is a set with one element, and that element is the null sign. So you cannot call this an empty set. I believe this is clear enough. Then we go to a unit set. Now, yes, we could use this example as a unit set. Now, this example has just one thing inside of it, the null sign. So we can call this a unit set. We can call this a unit set. So in another instance, let's see something like this. And let's see something like this. Now, the fact that there is a 0 here does not mean there is no element. The element here is 0. Are we good? Then for this is 1, the element there is 1. So they are just single elements inside of this set, so we call them unit sets. After that is clear enough, we'll go further to the next thing here. And it says union of sets. Then we will take intersection of sets, complementation, difference, symmetric difference, disjoint, cardinality, and then finally we'll take Venn diagrams. So as fast as we can, let's go straight into union of sets. Now, earlier before now, we were discussing under A and B when we started. I guess the black marker is easier to do, so I'll keep using the black marker. Alright. Alright, now, earlier from the start, let's take something very easy. I will grab your attention very fast. So let's say we have 1, 2, 3, 5, 7, 9. And we have B to be 2, 4, 6, 8, and 10. Now, I have been told to do the union of these two sets. Or, likewise, let's assume that we don't even know what union is all about. Alright? Now, somebody just looks at you and says, oh, if there's a way I could join A and B together. If I'm to join A and B together, mathematically, this is set A, this is set B. Mathematically, I am told to do the union of the two sets. Union of sets. So the union of A and B will give me the addition of the elements of A to the elements of B. And when I say addition, I don't mean 1 plus 2, 2 plus 4, 3 plus 6, no. What I mean is each of the elements in A combined with the elements in B. So we have 1, 2, 3, 5, 7, 9. Okay. Then put a comma and then carry on. 2, 4, 6, 8, 10. Now, remember something I said earlier from the beginning of the course, that in sets we do not permit repetition of elements. Now, in this case, you can find a 2 here and you can find a 2 here. Now, that means we cannot call this a set. Automatically, we cannot use this. We have to go back and write 1. Pick 1 out of these 2. Okay, 2. Go on, 3. You can choose to organize your work if you want to, but it is not compulsory. It is not actually mandated that you organize your writings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1, 2, 3 down to 10. I believe you get that point. So 1, 2, 3 all the way down to 10 is your A union B. Now I believe the next question or the next part is intersection and complementation. Now very quick and fast. Intersection of sets is given by this sign. Now, I believe many of you will say it's N, but it's not N actually. It's a sign that goes like this. Yes. So this is intersection. Now, what does intersection mean? It means this element and this element, what do they have in common? A intersection B. What elements do they have in common? What does A have that B also has? That is the meaning of A intersecting B. Now, please always remember that the arrangement of the elements matter. If it is a B intersecting an A, it is different from an A intersecting a B. Alright, so in this case here, we are having A intersecting B. What does A have that B also has? So we want to do for B that what A has too. So we could see that there's a difference in the arrangement of elements. Now, A intersecting B, let's go back to our works. A intersecting B, 1, 2, 3, 5, 7, 9, 2, 4, 6, 8, 9. Now, A has 1, 2, 3, 5, 7, 9. B has 2, 4, 6, 8, 10. The only thing I'm saying connecting A and B is 2. So, A intersecting B is just 2. And what do we call kind of set? A unit set with one element in it. Now, when you go to B intersecting A, now this is B. I'm using it now to check against A. What does B have that A has? Now, in this case, we're still getting the same answer because you're still finding just 2. B has 2, 4, 6, 8, 10, but A has 1, 2, 3, 5, 7, 9. So the only thing they still have in common is still 2. And so we still have a unit set as answer here. Now, the next thing we'll be looking at is the complementation of sets. Now, suppose that we have a universal set. Oh my God, my better sign is so bad. But then you're going to manage it. Okay. Oh, I got. You know what? Forget it. Let's do this. Yes. Now, since this is going to be easier to use, we will keep using this instead. The use sign. Not like I completely use, but something like this, the corrected. Actually, I didn't know calligraphy in school, so we'll just suspend that work for now. Alright, so yes, let me check on my phone. Hold on for me. Competition of sets. Imagine I had a general set of 1 down to 15. Okay? So my universal set is 1 to 15. My set A is 1, 2, 3, 5, 7, 9. My set B is 2, 4, 6, 8, 10. Now I have been told to do complementation. Now in complementation, I can use 2 signs for it. If I want to do the complement of A, I can simply put a strike on the head, A complement. Or I put a C on the top of it, A complement. So in any of these that you see in any standard exam or any standard works or any standard books, it's telling you to do the complement of the set. Now for set A, how do I do complement? That English is so big, I don't understand. So let's do it together. Now for set A, bring yourself all the way here now. Let's do this here. So for set A, this is A prime, A complement, which is actually the same thing. Okay, so the answer will be giving you what exactly is in the universal set that is not in A. That is the meaning of A prime. We call this A prime, we call this A complement, but whether prime or complement, it means the same thing. So what is in A that is not here right now, or probably what is in universal set that is not in A right now. Now A has 1, 2, 3, 4, 7, 9. Now if you observe from 1 down to 15, 1, 2, 3, there's no 4, 5, there's no 6, 7, there's no 8, 9, there's no 10, 11, 12, 13, 14, and then 15. So that means A is lacking 4, 6, 8, 10, 11, 12, 13, 14, 15. It doesn't have that. Not because they didn't give it to him, but because what he has is what he has. Okay, so at the end of the day, you have 4, 6, 8, 10, 11, 12, 13, 14, 15. Now this is A complement. How about B complement? B complement or BC, whichever one you want to call it. Now for B, I have 2, 4, 6, 8, 10. So that means I still have the numbers 1 missing, 3 missing, 5, 7, 9, then 11, 12, 13, 14, and 15. So looking at the universal set 1 to 15, B does not have 1, 3, 5, 7, 9, 11, 12, 13, 14, 15. 1, 3, 5, 7, 9, 11 down to 15. But don't write this. Let's write it full. 11, 12, 13, 14, and 15. Now, in set will not give you this. They won't tell you to do 1 to 15. They'll give you clearly 1, 2, 3. You might put it dot 1, 2, 3 down to 15. Alright, so let's be clear on what we write. Okay, now that is all for complements. Alright, then we'll go into other parts of the work. Let's look at what we call difference. Yes, let's look at difference. Now let's clear the other side of the board. I'm coming to clean the blue markers again, so that will take me a while. Oh, now it's easier to do. All right. Okay. Now let's see. Okay, the difference of a set A related to set B. So we're talking of difference. Okay, so let's use the example we still have on the board. So for set A is 1, 2, 3, 4, 5, 7, 9. Set B is 2, 4, 6, 8, 10. Now, A difference B is written as A backward slash B, sorry, not forward slash. Alright, A difference B. Now for A difference B, what it means is what are the elements that are in A but are not in B? What are the elements in A but then they are not in B? So let's go check. 1, 2, 3, 5, 7, 9. Now the only element that is in A that is not in B are many here actually, because I won't say the only element. There are elements, so many here that are not in B. Imagine this. When we did intersection, we said what does A have that B also has, which is 2. In this case now, they now said what does A have that B does not have. So it is the opposite of what intersection. And intersection is the opposite of difference. So now what does A have? 1, 2, 3, 5, 7, 9. What does B have? 2, 4, 6, 8, 10. The only thing common to the both of them is 2 and 2. That means B does not have 1, 3, 5, 7, 9. So we come here. B does not have 1, 3, 5, 7, 9. Shall we also do for B difference A also? Okay? Now in B difference A, what does B have that A does not have? Now B has 2, A has 2. But then B has 4, 6, 8, 10. A does not have 4, 6, 8, 10. So we go and write our 4, 6, 8, and 10. This is all about difference. This is all about difference. I believe these first concepts will be quick enough for you to grab. Now we'll go straight to symmetric difference. Yes. Now in symmetric difference, the only thing we will be doing here is that we are going to be adding, if you are told to do, now let me check this here, if you are told to do the symmetric difference of A and B, what it means is you do the difference of A to B, and then you add it to the result of B to A. Very simple as that. So how about we do for A and B that is here? Now don't forget we have gotten A difference B already to be what? 13579. 13579. Union, what do we have for B intersection? Sorry, for B difference A now. 4, 6, 8, 10. Now I have been told to do what? Take the union on both sides. Alright? So that means at the end of the day, we'll be having something like 1, 3, 4, 5, 6, 7, 8, 9, and 10. So this is the asymmetric difference, or the symmetric difference rather, of A to B. Now this is the sign we use for symmetric difference. It is a triangular sign. Many of you in chemistry know this sign as per change in, I left chemistry a long time ago. Alright, so next in set we have what we call a disjoint sets. Now disjoint sets are sets that don't have anything in common. In fact, from the name, disjoint. Alright, so they don't have anything in common. So let's look at disjoints. So for disjoint sets, I'll give you a very fast trick. Now for disjoint sets, once you see that a set does not have anything in relationship with the other set, it means that the set will be empty. Now once the set is empty, they are disjoint sets. Once you have an answer that tells you that the answer that the result is 0, or that there is no element in the set, automatically they are what? Disjoint sets. They don't have anything in common. Alright? Now for cardinality of a set, now I know that the English is very big, but what cardinality means, now everybody that, or as many people will want to check that. Now for these disjoint sets, once you have A intersecting B to be 0, or sorry, not even 0, to be what? Empty set, automatically it means they are disjoint sets. Now for cardinality, now my D looks like a snake. Okay, cardinality of a set. Now what it means is number of elements in the set, that is all. So if I have elements, sorry, let's set A to be 1, 3, 5, 7, that means cardinality of A, let me write this now, cardinality of A is 4. Now I taught something different in class, talk about the power of the set. Now the power of the set is not included in this outline I have here, but then it will be handy for as many of you that will work in mathematics in the near future. I know that some of you are already saying, God forbid, but then God will help all of us. Alright, so for power of the set, A is 1, 3, 5, 7. The power of the set is given as 2 to the power of the amount of elements in that set. So 2 to the power of, how many elements do we have here? 1, 2, 3, 4. 2 to the power of 4. Now, I'm in love with many of you who say it is 2 times 4, but there is not 2 times 4. Alright, I love you very much, but then I have to correct you here. Now, 2 to the power of 4 means 2 in 4 places. 2 multiplied by 2, multiplied by 2, multiplied by 2. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. Sorry to boss above, it's not 8, it's 16. So at the end of it, the power of this set is 16. Now that means I can arrange this set in almost 16 ways and it will still give me a standard set. Alright, I believe that is all we can take for now. The next video will carry Venn diagrams and the operation on sets. Thank you very much for watching. We'll catch you up next time.